around, and I want you to be able to easily move with me. So as a quick reminder, please use each other as a resource. If you get stuck, what can you still do? Like if you're a small group, well, first off, should any one person just be writing the stuff on the board? No, what do we need to do first? We need what?
We'll give the marker to different people.
Yeah, so spread out that marker, yes, but like, what's the design? Like, why do I want you to spread that marker or share that marker around? I want you to collaborate. I want you to talk. If one person's writing and y'all aren't talking about it, how many people are actually thinking and making sense out of it? The only one I know of is the one person writing, okay? One of the themes from the week 15 reflections, like the most common thing, which this was really exciting to see, the most common thing was that people felt like they were learning to collaborate and communicate better. Especially some people even said, I'm naturally very shy, or I'm quiet, and I don't like talking to people, which I get, okay? But it's not just, hey, learning the skill of collaboration. When you learn to collaborate and communicate, and you're willing to get outside your comfort zone and ask a question. It's like I heard Mary earlier, is like, okay, I need y'all to explain to me how you did this, right? Yeah. That's great, right? Like when you ask those questions, that's how you grow and learn. So don't stand in the background. Don't just let it, pass over you. There's only one of me and one of Mr. Javi, and we can't be at every group at all times. Make sure you're talking with each other, and if we come over and you have a question, ask while we're there. But I'm focusing my conversation right now based on some mistakes that I see. And they're beautiful mistakes. Make all the mistakes, learn and grow from them, okay? And so I pulled on a couple of these, and so I want to talk about this one really quickly. Small detail here. First things first, if I want to solve for y, all of us talked about this, if I want to solve for anything, I've got to use what? I got to use inverses with properties of equality, right? And so remember, the idea is that... I'm almost there. Does this equation and what we started with, do they look exactly the same? Jaden's saying no, right? Like I'm looking at this equation over here, and this equation right here, do they look the same? No, they look different, but they're telling the same story, right? So they are equivalent. I got to use a property of equality. So don't forget that. And pay attention, right? Like if you read what's happening to y, then you know what to do to undo it, right? It was the cube root of y, so a lot of us cubed it. But two things with that, right? So you'll notice I had to write in purple here, cube. If we cube the left side, we need to cube the right side. One thing I'm really, really, really proud of, and I want to emphasize this, and I need you to pay attention to this, is you cannot just cube the 0.14x and the 1.03. That's not what's happening. What you do to one side, you're doing to the entire other side, right? So all of us put parentheses around there. We all cubed that entire right side. Keep doing that, okay? You can't just cube each number or each term. You got to cube the entire side to be a property of equality, okay? And then I know some of us were like, and I know that's what you're thinking, Xander. It's like, I need to now distribute that cube. Don't. Do I know what y is equal to here? So am I going to stop there? Yeah, like, don't make your life hard. Now, one thing I do want to caution is right here. The way we have written it, and I talked about this with the group, and they learned from it, and I want us all to learn from it, we don't actually have the cube root here. What is actually being said right here? Do you know? Or do you know why it's not the cube root? It's close. Leah, do you remember what we talked about, why this is not the cube root right now? I didn't really even say it, but like, do you want to come up and like point where it's supposed to be, what you're referring to? So I kind of call this like the little crook of that root symbol. Do you know the term for that, Mr. Hobby?
I don't remember.
Yeah, I don't have a term for it. But please note, this is not saying the cube root. This is actually saying 3 times the square root. If it's out in front of the root symbol, it's a coefficient. It's not the root. So make sure that you're actually putting the 3 inside there. Notice how it's small and it's inside, not out in front, okay? So if you don't write inside, it's not a cube root. Good with that idea? Okay. Over here, Yep, over here, this is one of the most, so make sure in a minute you make a note of that to yourself if that's something that you think you need to know. Right here is one of the most important mistakes that I want us to learn from. And so we are kind of have a property of equality, but notice on the left-hand side, what are we doing with the 3? A power, right? It's an exponent, we're cubing, right? On the right-hand side, is that what happened? Well, this is not a log, this is an, where's that variable located? In the, that variable is located in the exponent. So what you created was an exponential, which is the inverse of a what? Log, right? So be careful about that. Learn from that, right? If we cube it, what do we need to do to the other side? We need what? Cube it, right? If we do 3 to a power, then we need to do 3 to a power. And so those would not be inverses, right? So here we cubed. Here we created an exponential, right? That's that inverse of a logarithm. So make sure we note that and be careful about that. Whatever you do to one side of the equation, you have to do to the other side. Okay. What I do want to point out is, and so learn from that, make a note to yourself about that. What I do want to point out right here is they did a phenomenal job with realizing, okay, I want to solve for x, so what do I still have to use? Inverses with properties of equality. And so remember, I said read what's happening to y, and so from there we use our inverses. It was a cube root, so we cubed. When I look at this x, what's the first thing happening to x? Now look right here, what's happening to x first? Think about your order of operations. Good thought? It's being multiplied first. Doesn't multiplication happen before addition? Okay, so it's 0.14 times x, then what's happening to 0.14 times x? It's being added. Notice, Peyton, how we said the adding last? Because the last operation being done is the first one we want to undo. Right? That's why we subtracted 1.03. So remember, we undo in the reverse order. And so we get the cube root of y minus 1.03 equals 0.14x. And then notice, what do we have to do? Divide, right? And they actually did a phenomenal job of dividing here. And notice once again, what we did to one side of the equation, we did to the complete other side. Notice, they divided everything by 0.14. That's fantastic, right? Make sure that we divide the entire other side by 0.14. What's the only thing I would change slightly from that final equation? Anyone know? That is an x. That's just how they wrote their x. Look again. The little root, the index, right? We need to make sure that 3 is not a coefficient. We make that 3 an index. That is the correct term for what it is, right? So it's got to be inside that little crook. But phenomenal job. I do want to also point out, phenomenal job on making sure that we don't put the 1.03 under the root, right? That 1.03 is outside the root, so make sure we're careful about that as well. Mr. Hobby, was there anything else conversation-wise you heard with groups that we want to learn from that I missed?
I think we covered just about everything.
Okay. What questions do you have at this point before I have you look at, so what we should be looking at is lesson 4, connecting the algebraic and graphical nature of inverse functions. Hopefully we have something like that. Literally, we already did this, right? What questions do you have before you need to make some notes to your future forget yourself? Questions going once? Questions going twice? Okay. You should already have this worked out for A, B, and C there. Notice I literally chose the cube root. You should have something similar What I want to encourage you to do at this point is to write any notes about mistakes you think you need to be careful of avoiding and learning from. Thank you, I'll come grab that in a second. So, write to yourself any notes for what to do correctly in the future, any notes that you need to make sure you're careful of avoiding, because it's great to make mistakes, but we want to learn from them. Ask Mr. Javier or myself if you run into those questions. Recap from lesson 3 that we already did. Why was it that, so remember I gave you data, we looked at the relationship between how fast someone was driving and how long it takes them to stop. We looked at how many RPMs a boat has and how fast that boat was moving. And finally we looked at how much time went by and what temperature a cadaver, a dead body was, right? So why did we make that data linear? And how did we determine how to make the data linear? We what? We linearize it, yes, but why did we linearize it? Say it again. It's easier to graph and figure out a model or relationship, right? Like, at the end of the day, there's infinitely many curves out there, but there's only a few, not a few, there's less lines-ish. Gets into this weird concept that there's different sizes of infinity, won't get into all that. But it's easier, at the end of the day, to draw a line through a set of linear data, okay? But why did we take a cube root in that boat's situation? Why did we take a cube root in that boat situation? What did we say the data looks like? A cubit. The boat's one, right? Not the dead body one with the temperature dropping, but the boat one, we said, hey, that data looks cubic, so let's take a cube root. And it made it pretty linear. With the dead body, we said the data looks pretty what? Start with an E. Exponential, and so we discovered out of that, what's the inverse of an exponential? A logarithm, right? So whatever it was, we linearized it by using the inverse operation. And so it's easy to develop models when we linearize. I didn't tell you all this because we were running out of time, but one thing to be aware of is when you use computers and statistical software to create models like this, apparently, and I didn't realize this until a professor of mine at UA told me this, the statistical software a lot of times, or historically, actually use an operation to linearize the data and then figure out what the model is. So what we did is literally what computers do, because it's easy to fit a curve or a line to a set of data. Harder with curve. All right, so here's what I need us to pay attention to as a reminder before we jump into today. So I talked about this last time. 4 cubed is equal to 64, and the cube root of 64 is equal to 4. And notice my inputs and my outputs what? They swapped places, right? There's a mathematical term for that though. Do you know what it is? Creates inverses. But no. Say it again. Transpose. I think I have it up here. So be aware that that term, transposed, literally means the inputs and outputs switched, right? So guys, what made these inverses? Look at those equations. One of them has a y and one of them has an x for the what? What are you referring to?
On the left side equals.
So on the left side, what would we call that? That's the... Say it louder. Are these my outputs over here? Okay. So the outputs switched, and what about my inputs? They switched, or transposed. What's making my inverse function? The inputs and the outputs are transposing. Okay, that's it. This is not something I planned, I just thought about this. So if I call this f of x here, this would be the inverse of f of x. Be aware, I'll talk about this a little bit later, I'm just introducing it here. You see how that has a superscripted -1? Notice I did not call it an exponent. A superscripted -1, that just means inverse. Okay, so superscript -1 means inverse. Okay? So, anyone know what, if this is what my function is, anyone have a guess what my inverse might be? Say again? Well, this is an entire function, isn't it? I've defined it this way. Brianna, remind me, when we say an inverse, what's happening? Like at its core, the inputs and outputs are what? Transposing. So this -3, what's that going to become? That's going to become a y. It's going to become my output, right? What's its input? Okay. What's the next point?
8, 4,
Mm-hmm.
10,
Oh, that's it. So I didn't want you to just see it algebraically. I just thought about that numerically. Like when we say they're transposing, literally every input and output is switching. Okay. So it doesn't just have to be algebraically. It can be numerically in a table. It can be graphical. Just be aware, like the inputs and outputs switch. There is on the Frere model, I just thought about that. There's a section, I think, that if you look in the top left, it actually says inverse functions graphically and tabularly, right? So just maybe a quick example on that Frere model or on that sheet of paper. Just make that quick note to yourself. Hey, those inverse functions, the inputs and outputs transpose. That's all it is. Those inputs and those outputs transpose. Now, that's the core defining feature of inverse functions. It creates interesting properties when we look at the algebra, when we look at the graphs. And so these are things, like, there's no way really, unless I just have you Google and do research would tell you the same thing, for you to know that idea of the inverse, the inputs and outputs transpose. So I'm giving you that up front, but that's the foundation for those interesting principles that we're about to see in equations and in graphs, okay? And so I've set it up to this point where we should be okay. We should already have this information here. Your transformed linear model, notice I used this one. And I have dropped off the hat. I would go back and put the hat at the end for the prediction, right? Notice this time I'm predicting the speed based on the RPMs. What am I predicting here? Right. So instantly, there's a whole lot of power in using the idea of inverses, because what am I predicting? Completely different variable, okay? Now, what I do want to point out before I get you to do the graph, this is something you can do on your own. Before I get you to do that, one thing I do want you to notice is when I say right here, y equals f of x, I'm just indicating that x is my what? What's x in this situation? Starts with an I.
Input.
It's my input. Whew. There we go. Notice I'm saying x is my input, y is my output. So when I say x equals g of y,
Y is the output. What?
y is the input, x is the output. So please understand, all I am doing is showing that these are inverses. This is a notation to show x and y transposed. That's all I'm saying there. So that's a notation to show that x and y transposed. Okay.
What page is
This is page 1. It's the same page you've been writing all this on, isn't it? On lesson 4? We're on lesson 4. Right here. That's where you've been.
I thought it was
Mm-mm. Nope. That's at lesson 4. Page 1 is task 3 from lesson 3. I will point out, I mentioned it earlier, so this is the vote and RPMs one. This is the second one that we actually worked on. I skipped the one about braking speed, or distance to brake, because there's a unique feature of that one. Okay, so now what I'm going to have you do is, I'm just going to have you graph both the model for the original data and for the inverse function. Okay. Now your calculator can only accept the variable x as an input. So even though my input's actually y, what am I going to type into the calculator? I'm actually going to type in an x there, okay? And so what I need you to understand about this is we have 3 tasks to really build our understanding of what's happening. I don't need you to get the answer right. I just need you to come up with a prediction. Just once you graph both of these functions, what do you notice and what do you wonder about the model and its inverse? I'm not going to tell you if you're right or wrong at this point, because we're going to build to a complete understanding at the end. So, what I need you to do is I need you to create a graph page. You can add a new page on the calculator or just go to a scratch pad. But I need you all to work with each other on graphing the original function and its inverse. What are your questions about those directions? When you graph those, what I want you to do is, again, just think through, what do you notice about how those are related? So I should say that. What do you notice about, and what do you wonder about how the graphs are related? Talk with each other, come up with one prediction, and put it on your vertical surfaces. That's it. Graph your 2 functions, come up with a prediction about how you think they're related, and we'll come back. So they both look to be one-to-one functions. When I look at these 2 functions graphically, do they look to be one-to-one? What do you think?
Yeah.
100%, right? They look to be one-to-one. I'm good with that. Looking around the room, I know we don't have all the predictions. I didn't give a ton of time, but we have to get going. Elizabeth's group. Okay, so first off, I like this. Is g of x an exponential function? What do y'all think? Or g of y an exponential? Elizabeth, you shook your head no. Why not?
zoomed out on one.
Huh?
You zoomed out, it looked different.
Okay, so if we zoom out, it doesn't look exponential. But guys, look at those equations as well. Why not?
Power than 2.
I would say we have, remember, if it's exponential, the exponent is a what? Say it louder. If it's exponential, the exponent is a, not a cube, it's a, yeah, the exponent's an exponent, but what is the exponent? An x, a variable, thank you. Woo-hoo-hoo. If it's an exponential, that variable is an exponent. Guys, what type of function is f of x? A cubic, right? It's cubed.
Yep.
What kind of function is g of x? Or g of y? Well, let me ask you this. How would you read this? The cube root. So you know what type of function this is? A cube root function. That's it. It's a radical function. So like you have polynomials, the squares, the cubes, the fourths, powers. This is a radical function because it's got a radical. It's just a cube root, okay? So notice it's not exponential. I love that prediction, but do notice we have those things. So right here we have, and then Elizabeth's group said the same thing, use each other's resources. Yeah, the functions appear to be a reflection. Does anyone have it further zoomed out from this?
I have it to where you zoomed out.
Okay. Where did it go? I just saw it. So this one's a It's not perfect, we can't fully see it, but I want to point out, you see how this is pretty flattened out right here? See how it's pretty flattened out right here? And it starts to curve away again, it's just like it starts to curve away here. So, do they look to be some kind of reflections? So, we're going to ask the question, are inverse functions reflections? That may be a key that we want to build on. But if they are a reflection, we need to know what the line of reflection is. Okay? And we can't just look at one example. All we've done is look at one set of functions, right? We need to look to see if that's always going to hold true. So, make a note to yourself, ask that question on that part D right there. Hey, are inverse functions reflections? If so, what is the line of reflection? That's the prediction we're making. What did you say, Miles? What did you say? Be careful. The reason I say that is the word opposite. I'll write it down in a second, but this is to help you with part E. Okay? So a crash course in composing. All right? There's other notations for composing. I hate them. They don't make sense. I'm sure there's a reason I'm just not aware of. But composing crash course. If I were to tell you f of x equals x squared minus 3, and I were to tell you g of x equals x plus 7, and I were to ask you, hey, what is f of g of x? What does that g of x take in the place of? What was right here originally? X, right? So what's that g of x going to take the place of? Okay, that's it. It's being substituted in for x. You'll see this on the ACT. It shows up pretty consistently once or twice every test. This idea of composing or substituting in. So we're just going to substitute g of x in for x. Okay, here's my x. And notice I'm going to do it with the f function, right? So there's my x. So what's taking the place of that x? And we said we're going to substitute g of x in.
Is it x plus 7?
Okay, so that x becomes x plus 7. There's g of x. That's it. That's f of g of x right there. You look at me like, what? I'm done. You can simplify it further if you want, but you definitely don't have to. Sometimes you definitely will want to. In a similar way, if I were to ask you what g of f of x is, what took the place of x this time? F of x, right? So notice I'm going to use which function? I'm going to use g of x, right? Like I want to know what g of x is, right? But what took the place of x in g of x? F of x. So what's going to go right here?
X squared minus 3 plus 7.
X squared.
X cubed. Wait, hold on.
Well, so notice like this is it's not, yeah, it's being substituted in. It's taking the place of that x. So x squared minus 3 plus 7. Notice that just took the place of x. That's it. It was substituted in the place of x. Now, I will point out, is there an easy set of things that I could simplify here? What would it easily simplify? So like nothing easily simplified there, so I didn't sweat it. Say again? Negative, yeah, what is negative 3 plus 7?
4.
So same thing as x squared plus 4.
Yep.
That's it. So this is a crash course on composing. It's going to help us discover an important property. You get it? All right, I'm going to do one more, and I'm going to leave it up here, so don't erase this so that people can look at it in a second. Let's say this time, I'm going to have h of x equals x, let's go with the square root of x. So I'm trying to think what's going to be the most helpful for you in the next piece of this. Ah, there we go. Okay. Now, what I want to find is f of h of x. Okay? What's the h of x? So notice I wrote h of x, I still have f of x here. What's the h of x taking the place of? X. I mean, substitute in for x, right? But which function am I going to use? I'm going to use f of x. See how that's the outer piece? So what's going to take the place of this x, right? So I've got my x squared minus 3. That's f of x, but what's taking the place of this x? Square root of x plus 2. So, pay attention, whatever the outermost function is, that's the function you're really dealing with. The one on the inside literally is my input. That's it. That's what I want you to think about, is what's on the inside is my input. The outer one is what I'm substituting into. So inner, input, outer, what I'm substituting into. Is there anything there that simplifies really nicely? The square root and the square, right? You see how they're like right next to each other, just as if they were inverses, canceling each other out? Okay, so square root of x plus 2 squared, those are inverses, and so I'm left with and minus 3, right? Is there anything there that easily simplifies? 2 and negative 3, so that would just be x minus 1. So, if there's nothing that simplifies well, don't sweat it. If there's some stuff where it's like, man, those are inverses or those are easy to simplify, simplify them. That's the general rule of thumb that I would go with. Pay attention though, if you actually have inverses there. Okay, so that's that composing crash course. I'm going to give you all probably 5 minutes. Doesn't have to be perfect. I just need you to engage in thinking about this. What I want you to find is, and let's do this, aces through jacks. I want you to work on g of f of x. And 10s, 9s, 8s, and 4s, I want you to work on f of g of y. Okay, so remember you have f of x and you have g of y earlier in that set of problems, right? If we're going off of what we worked on in the board earlier, f of x was 0.14x plus 1.03 cubed. G of y was the cube root of y minus 1.03 divided by 0.14. Okay. So work on composing those two. You each these are my aces through jacks. This is the rest of us. Just work on trying to compose them. See if anything simplifies and if there's any patterns or predictions we can make from that. Okay? So think about that crash course. Try applying that information. Remember, the vertical surfaces are where I recommend you work and you talk because there's plenty of space for you to make mistakes, erase, and start again. All right. A couple more problems with this to really start to build the foundation. You don't have to have the procedure mastered yet. But here's what I want us to pay attention to. First things first, right? When I say g of f of x, what did this take the place of? What did f of x take the place of? Of y, right? Literally, it was g of y. Now, f of x is in the place of y. So wherever there was a y, what's taking the place of it? That f of x. So guys, I know that that's an uncomfortable thing, but I was telling someone this, I don't remember who I was talking about this with earlier. It is something that like on the surface, I think it was Drake, that on the surface is like, what? And then when you get comfy with it, it is super quick, super easy. We just need to recognize that this f of x is being substituted into the g function. F of x is taking the place of y. So that gets substituted in for y. From there, you need to be careful, and I want y'all to pay attention to this. Here, it's a very natural thing to say, oh, the cube root and the cube cancel, which are the cube root and the cube with each other, like right next to each other? Yes, thank you. Liz was like, yeah, they're there, right? What's the cube root of a cube? They are, starts with an I, inverses, so they cancel each other out. And then notice, and be careful, because I'm going to show you an example where it doesn't work like this right away. But 0.14x plus 1.03 minus 1.03, what is that? 0. And we're still divided by 0.14. And then we're left with just 0.14x divided by 0.14 is equal to x. So g of f of x is equal to x. Now I need y'all to look at this right here. And this is where I need you to be careful. The most common thing, this is what the group over here did originally. So first off, what's g of y taking the place of? It's taking the place of x. So wherever there was an x, what's taking the place of that x? G of y, which is this thing, right? It's now taking the place of that x, okay? So that's where this came from, right? We have the 0.14 times, right here was x, but that's x. That's what equals x. And I need you to pay attention to this. You got to pay attention to your order of operations. Is that cube and the cube root, are those right next to each other? Or are those the term or the operations that are working with each other right now? I was like, no, not quite, right? When I think about order of operations, yes, ma'am.
Why you put it in brackets instead of parentheses?
You can put it inside of parentheses, but since I already had a set of parentheses, I did brackets. They just group.
Okay.
You can do parentheses. A very common thing though is to alternate. So if you have parentheses on the inside, you use brackets outside of that, just so they don't get mixed up. I don't know if you ever looked at it, but if you actually do multiple sets of parentheses on the calculator, it's easy to get lost. That way you don't get lost. That's it. You don't have to. Yep. Good question though. You can get a piece of candy for that later. All right. But paying attention to this, like here's y. Read with it, the cube root of y minus 1.03 divided by 0.14. Are there any like terms right there that I can do anything with? Like just right inside of here, are there any like terms? It's outside of there. What's happening after that division by 0.14 if I follow my order of operations? Not adding. What happens before adding? Multiplication, right? This multiplication. I got to follow the order of operations. What is 0.14 divided by 0.14 though? So the cube root, actually I don't even need that anymore. Cube root of y minus 1.03 plus 1.03 cubed. Okay? So cube root of y minus 1.03 plus 1.03. What's the, remember, I got to do parentheses first, so inside of those parentheses, or in this case brackets, what can I simplify? Plus 1.03 is 0. Notice cube root and cube are inverses, so I'm left with just y. Notice, and Elizabeth, this is what I was talking about in the previous problem, the one that y'all had. It's really important to pay attention to the operations because it's super common to just cancel the cube, right? First, like that's the most common thing students do here, but it actually doesn't work out the right way. The cube root and the cube in this case are the last operations that are inverses, okay? So you have to pay attention to your order of operations to how to simplify correctly. Because if you don't, things can work out kind of wonky and incorrectly sometimes, I will say that. So what's the prediction about inverse functions? What happens when you compose inverse functions? Nothing? Notice over here we got g of f of x equals x, f of g of y equals y. What's going to happen when you have inverse functions and you compose them?
Transpose?
Well, so the definition of inverse functions is that they transpose, right? The inputs and outputs transpose. What I'm saying is, what's happening here if they're inverse functions? Let me ask it this way. Let's say I have h of g of z, and I'm making something up here, but if they're inverses, what do you think h of g of z might equal? Okay. Because what's happening?
Oh,
If they're inverses, what's happening with these two functions? They are... Say it. Someone said it. They're canceling each other out. If they're inverses, what are they doing? They are canceling each other out, right? Like completely and entirely. One thing I do want to point out, remember, when we use inverses in the past, it's always created what two numbers? Either a 0 or a... Hey, quick question. What's the slope of this function right here? So g of f of x is equal to x. What's the slope of that function? What is it? The slope is? So 1. And what's the y-intercept? Oh. So those inverse functions created 0 and a 1. They're inverse functions, okay? One last thing before we get out of here. So I'm going to give you a chance to write that down, but I do want you to see this. So notice graph the composition. Nope, that's not what I want. Elizabeth, because I still have yours up here. Elizabeth, can you type in y equals x into that graph? So leave this graph here. Add y equals x to it. So add a new graph, or hit menu, yep, y equals x, just equals x. Yep. Oh, I don't think I have you as a presenter, that's the issue. There we go. So I want you to notice something. We thought maybe it's a reflection. If I reflect across this line, does it get me to a similar point? Yeah? If I reflect this across the line, does it get me to a similar point? Yeah? So, remember I mentioned this earlier, if it's a reflection, we have to know the line of reflection. What's the line of reflection for inverse functions? What do we just graph? It's a reflection across y equals x. That's it, right? Those inputs and outputs transpose. Notice literally y equals x, isn't that just the input and just the output? We're reflecting across that line y equals x, so inputs and outputs transpose. That's also why, if they are inverses, notice I said if inverses. If they don't come out to equal y or equal x, you know what they are not? They're not inverses. They can still be functions. That just means they're not inverses, right? So, dang it. If you're gonna, I understand we are low on time. So, if you need to, make sure you take a picture and put this into your notes of this idea of composing and seeing that they cancel out. But make sure that you have this note to yourself. For sure, this is a huge idea for inverse functions. We will continue to use this and verify this tomorrow, practice with it tomorrow, which means we'll have a demonstrated understanding on Wednesday through this lesson. Test will probably be on Friday then. And it will be a shorter test, like half the block, and then we'll start focusing on logarithms at the end of that. Have a great rest of your day.